In this lesson we will be looking at more exponents. The first ones we're going to talk about is the very important exponent of 0. What is the power of 0? Well, first of all, let's go back and review. If I have 2 divided by 2, what is that? Of course, that equals to 1. X to the 5th divided by x to the 5th is also 1. But what did we learn in our last lesson? If I had the same base and I was dividing, I kept the base and I subtracted the exponents. Well, 5 minus 5 is 0. So x to the 5th divided by x to the 5th is x to the 0. But we also know when we divide a number or an expression by the same expression or number, it divides in there one time. So we can conclude that x raised to the power of 0 is equal to 1. In fact, not just x, but any real number other than 0 raised to the power of 0 always equals to 1. The next type of exponent we need to look at are negative exponents. First of all, again, let's go back and review our rule that says if I have the same base, I would keep the base and subtract the exponents. 5 minus 2 is 3. That's easy. But what if it was the other way around and there was the smaller number on top? Well, if I kept the base and subtracted the exponents this way, 2 minus 5 is negative 3. And now all of a sudden I have a negative exponent. Well, let's go back and say, what if I didn't know that? If I just wrote out x squared is x times x and x to the 5th is that, and I said, well, I could reduce, that goes in there one time, that goes in there one time, so that's 1 over x to the 3rd power. Well, those both have to be equal. So we can say that yes, x squared over x to the 5th is x to the negative 3, but we can write it as a positive exponent by taking the reciprocal of that base. So again, our conclusion is if we have something raised to a negative exponent, we can rewrite it as a positive exponent by taking the reciprocal of the base. Rewrite a negative exponent as a positive exponent by taking the reciprocal of the base. So that's what we need to practice, making negative exponents into positive. Right? So if I have 2 to the negative 4th, it does not equal negative 16. What does it equal? Well, we take the reciprocal of the base and change the sign of the exponent. And that is 1 over 16. 1/16, much smaller. Right, so here 1/3 is the base, so I'm going to take the reciprocal of 1/3, which is 3, and change the sign of the exponent, and that's just 9. 3 over 1 is the same as 3. 3 squared is 9. So those are the two rules we're working with, in addition to the rules that we learned in the last lesson about exponents. So let's apply those rules by evaluating these expressions. And remember, evaluate means we're having a numerical answer. So number 1, what's our base? Negative 2. Negative 2 is the base raised to the power of 0 equals 1. Here we're going to do that negative. We're going to be really careful. What is our base? Not negative 5, but just 5. So that means we need to keep the negative. We need to change our negative exponent to positive. How do I do that? I take the reciprocal of the base. So again, bring down that negative. Now square that. 1/5 times 1/5, which is 1 over 25, but that negative stays in front. Number 3, just sneaking that in from the last lesson. Remember what that is? That doesn't have a negative exponent, but that has a negative base. Remember, if we have an even amount of negatives, that's going to be positive 16. All right, let's look at number 4. We have a negative base raised to a negative exponent. Do they undo each other? No. What we have to do is change that exponent to positive by taking the reciprocal of the base. A reciprocal keeps the same sign. It does not change that. But we're changing the sign of the exponent to positive by taking the reciprocal of the base. What does that mean to do? Well, when you square a negative times a negative is a positive. So 4 squared is 16. 3 squared is 9. Now look at number 5. We have a bunch of negative exponents. We could flip, 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 but let's apply those rules we learned in the last lesson. If you have one base and you have a power raised to a power, what can I do with that? I can multiply. So keep the base, multiply the exponents. Now I don't have a negative exponent to deal with. I just need to know that 2 to the third power, of course, is 2 times 2 times 2, which is 8. Now let's look at the same thing. Number 6, again, I can keep the base and multiply those exponents, but this time I still keeps it as negative 2. So I have to change that negative 2 to a positive 2 by doing what with that base? Taking the reciprocal of that base. And now squaring both of those, and I get 16/9. Let's look at just a few more. Well, I have the same base dividing, and I could keep the base and subtract the exponents, but I'm telling you now, you're going to have a lot of troubles with all those negatives. So let's get rid of those negatives. Let's do this. Let's keep the 2 to the third power right where it is. But let's change that. Let's take the reciprocal of that, which would be 1/2 to the first power. Now I don't have any negative exponents. I can keep the base and add those exponents. And now I can evaluate that, and that's 1/16. You could have gotten there by subtracting and dealing with all those negatives, but please, 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 let's just make those negatives as positives when you can. So let's see, could we do the same thing with number 8? Well, what's the base? It's negative 2. If I add those, adding is a lot easier than subtracting. Alright, so that's why I'm going to go ahead and add those, and I get a positive 3. Now I don't have a negative exponent, and remember that's negative 2 times negative 2 times negative 2. 3 negatives in a row is negative, and then you have 8. So we can combine those rules that we learned in the other lesson, in addition to the fact that we can change negative exponents into positives, and anything raised to the power of 0. I'm going to go back up to here, number 1. So number 1 was negative 2 to the 0, which equaled to 1. But what if I had it like that? Would that also equal to 1? No, because just that is raised to the power of 0. That negative would stay, and this part is 1. Got to be careful. Now let's apply them to algebraic expressions, and we're going to simplify these expressions, and we don't want to write any answers that have negative exponents. All right, all exponents should be positive in our final answer. Okay? So we can work these problems lots of different ways. The first thing I'm going to do is I'm going to try to make everything positive. So what is that? That's 1 over x cubed times 1 over x to the 5th, which is 1 over x, same base, add those exponents. Could you have worked it a different way? Yes, you could. You could have said, hey, Ms. Turnell, I have the same base, so I'm going to add those and I'm going to get negative 8. And I'm going to say, yes, that's right. But then you have to write it like this because I want to write it with just positive exponents. Be careful. So let's see what happens if I do it that way. If I kept the base and added all 3 of those, what do I get? Well, negative 4 and negative 5, that's negative 9 plus 9. Oh, that's 0. And what's anything except 0 raised to the power of 0? That is 1. Let's look at number 11. We don't have any of the same base. Remember that rule? We had that kind of distributive property on those exponents. Same thing here. So I have x to the positive 6, negative 3 times negative 2 is positive 6, and y to the negative 8th. Cannot leave my answer like that. Don't want to leave any negative exponents. So since this is positive, it's staying right where it is. This is like over 1, so the y is going downstairs and changing that exponent to positive. That's the same thing as taking the reciprocal, y over 1, 1 over y. That's your final answer. All right, number 13. Again, I could keep the base and subtract, but I have too many negatives, so let's go ahead and make that positive by taking the reciprocal. That stays right where it is since it's positive. Now I can keep the base and add those exponents. How we doing? I hope okay. All right. Number 14, I can do lots of things in lots of different orders, but the first thing I see is I have negative exponents. So I'm just going to keep everything exactly like it is, not doing too many steps at one time. And I need to make that a positive exponent. So since it's in the numerator, I'm going to go down to the denominator and change the sign of the exponent, just like I did on number 11. And since this one's in the denominator, I'm going to bring it up to the numerator and change the sign of the exponent. Am I done? No. But at least now I have all positive exponents. Now I'm going to be reducing. So 9/12, those are both divisible by 3. So I have 3/4. Here, now, we can keep the base and subtract, but I want to do that where I have a positive number. So if I went 2 minus 4, that would be negative. I don't want to do that. So what I wanted you to look at is say, there's more x's downstairs. So let's keep the x downstairs and subtract 4 minus 2. And now we have a positive exponent. Same thing with the y's. Where are there more y's? Top or bottom? On the bottom. So I'm going to keep the y on the bottom and subtract the biggest number minus the smallest number. Keep in mind, if you have x squared over x to the 4th, that's the same as x times x over x times x times x times x. And you would get 1 over x squared, which is what I ended up with. All right, so again, working with positive exponents are so much easier than working with negative exponents. Last two examples, yep, bit harder. All right, take it step by step. Don't try to rush and don't try to skip steps. So the first thing I'm going to do is I'm going to get rid of those parentheses by distributing. So that's 3 to the negative 2, which is not negative 9. X to the negative 2, y to the negative 8th, times negative 2, and I'm going to put that in parentheses knowing that that's my whole base, to the negative 3, x to the negative 6, and y to the negative 9. Look at all those negative exponents. Yuck. Now keep in mind, that's all over 1. So since all of these exponents are negative, and I need to make them all positive, I'm going to take the reciprocal. So I'm going to put the 1 on top, and all of these go to the bottom, and it changes the signs of the exponents only. See how I'm still keeping that negative 2 in parentheses, reminding me that whole thing is raised to the 3rd power. All right, let's do some of the letters. X squared times x to the 6th. Keep the base, add the exponents. The y's. Keep the base, add the exponents. Now what is 3 squared? Well, that's 9. What's negative 2 times negative 2 times negative 2? That's negative 8. If I multiply that together, that's negative 72. That's your answer. Now keep in mind, negative numbers we can keep. just where they are. It's the negative exponents that we have to move. Exponents. Alright, let's look at number 16. So I'm going to clear the parentheses, I'm going to change all the negative exponents to positive, and I'm going to reduce. So I'm going to clear the parentheses by distributing that negative 2 to everything inside here, including the numbers. Make sure you do it to the denominator as well. Also, I have a negative 2 times a negative 3, that is positive 6. And then when I multiply that, I get a positive 8. So I've cleared the parentheses. Now I'm going to change all negative exponents to positive, which means that one, and that one. How do I change them? I move them. So this was upstairs, so it goes downstairs. This was downstairs, it goes upstairs. And this goes downstairs. Well, what about everything else? It stays exactly where it was. All right. Now, reduce, clean it up. Let's see what I've got. So 5 squared is 25. 4 squared is 16. What can I do with those x's? Where are there more x's, top or bottom? On the bottom. So I'm going to keep the x's on the bottom, and I'm going to subtract 6 minus 4 is positive 2. Then those are both on the bottom, so I'm going to keep them on the bottom and add their exponents. Again, skipping steps with this is not a good idea. Be careful about what you can change, what you can't change. Negative exponents you have to change.